All right, good day everyone. So at this point of time, let us talk about continuous probability distribution. So continuous random variable. And this is Kasaligan laws. So continuous probability distribution, when the random variable of interest can take any value in an interval, it is called continuous random variable. Every continuous random variable has an infinite unaccountable number of possible values. So this is a graph for discrete probability distribution and continuous probability distribution. We are done discussing about discrete probability distribution, so therefore we will proceed with continuous probability distribution. So understanding the probability distribution, so a probability distribution below distribution describes how the values of the random variables are distributed. So there are the probabilities distribution can either be discrete or continuous. So in continuous probability distribution, the random can take an infinite number of values, and like in discrete, where the probabilities are assigned to specific values, as a continuous distribution is described using probability density function. So we are now in PDF. So the key difference between the discrete and continuous distribution is that in terms of the values, that is countable, and infinite and continuous, that is infinite within an interval. In probability representation, so in discrete, we're using probability mass function, and in continuous distribution, we're using probability density function. For probability of single value can be non-zero and always zero. An example of this one is the number of students in the class, and continuous is the height of students in the class. So we are now using the PDF and we are done with PMF. So continuous. So the concept probability density function. So a continuous probability distribution is characterized by a function known as probability density function, or PDF. Unlike in discrete probabilities, when you assign a probability directly to each outcome, the PDF describes relative likelihood of the random variable taking on the value near x. So there are key characteristics of PDF. The first one is non-negative, and the second one is normalization, and the entire range must be equal to 1, the total area. And for zero probability at specific point, for continuous variable, the probability of variable taking any value exact is zero. Probabilities are instead calculated in this way. So by the use of integral calculus, or by use of integration. So what do you mean by zero elsewhere? So the role of zero elsewhere is that when specifying a PDF, it is common to see the function defined over a specific interval with notes such as zero elsewhere. So what this means indicates that the random variable has no chance of taking a values outside the defined interval. This means that the function f of x is only non-zero between a and b, but outside the range, the probability is zero. The phrase zero elsewhere just indicates that no probability must exist outside the given range. So, for example, of this uniform distribution, we the commons to see the function defined over a specific interval with a note zero elsewhere in a uniform distribution, meaning say that outside the range, the probability density is zero, and ensures that the total probability sums to 1. So the probability density function can be used to describe the probability distribution of continuous random variable. So this one, take this one, that we are using the probability density function. Okay, so this one. So the properties of probability, so what we're going to look for is that this is non-negativity. So when they say the fx, or the function, is greater than, when subject to the value of x, all the y should be greater than or equal to 0, or its density function must be non-negative for all values. So the totality of probability is 1, and the integral over the entire range of possible must be equal to 1. And the probability of interval, the probability is within the interval AB. So this one. So the domain of probability density function is usually R, that is the variable is continuous and can assume any real value, at least in theory. If we need the function to be non-zero over a particular interval, say 0, say over interval, they need to specify that the function is equal to 0 elsewhere. So that's why we have 0 elsewhere. In such case, the area under the curve between x and a, x and b must be equal to 0. So this one, equal to 1 rather. The integral of f of x dx from a to b is equal to 1. So let us start first with problem number 1. How to identify? We need to identify or sketch of each of the following and state whether the function may be probability density function. The first thing that we're going to do is we need to sketch. So we have here, you have to sketch. So for 4x, the function 4x, the interval is 1 to 2. So therefore, when you substitute the value for 1, the result is 4. Assuming this is 4, yeah, 4, this is 1 and 4, and we substitute the value of 8. Assuming this is 8 here. So this one is 2, and this one is, so this is 2 and 8. Okay, within this interval, okay, so we need to have the probability density functions, or the probability within this interval 1 to 2, that is inclusive 1 to 2. So beyond this interval, so the probability density function is 0 elsewhere. So the first thing that we're going to do is we need to determine whether the function is a probability. So the first is the function need to be PDF. It has to be positive or non-zero the entire domain. So in this case, let us case number 1. So f of x is greater than or equal to 0 for all x. So that's okay. That's because when you substitute the value for x, all is greater than 4 and 8. So that's it. And the second one is that we need to find the area should be equal to 1. So it should be the area should be equal to 1. So area is from integral of 1 to 2, that is 4x dx, because the interval is 1 to 2. So we need to integrate this one. So this is 4x squared over 2 from 0 to, no, from 1 to 2. Okay, from 1 to 2, that is, the area is equal to 2x squared. 2x squared. Okay, from 1 to 2. After the 1, we have to substitute the value. So area is equal to 2 times 2 times 2, then squared, then minus 2 times 1 squared. So the area is equal to, this is 2 times 2, that is 4 times is 8, minus 2. So the area is 6. So the area under the curve is not equal to 1. So therefore, f of x could not be a probability density function because the area is equal to 6. So the first case or the first property is correct, but the second property does not follow that the area is should be equal to 1. Okay, so next we have in this case, if it does not follow in the first case, so therefore it would not represent a probability density function. So in this case, letter B, f of x is equal to 10x minus 4. The interval is x is greater than equal to 0 and x is lesser than equal to 1 where 0 elsewhere. So the first property, we need to sketch the graph here. Okay, need to sketch the graph. When we substitute the value for our interval 0, if this is 0, this is negative 4. Our x is 0, this is 1, 2, 3, 4. So this is 0, negative 4. And when we substitute the value for our 1, substitute 1, that is 10 times 1 minus 46. So 1, then 1, 2, 3, 4, 5, and 6. Okay, that's 1. So the first property that f of x is greater than or equal to 0. Since when we substitute the value for our 0 here, and this become negative 4, so therefore the first property is the f of x is not positive or 0 for all x as part of the graph below the x-axis. So therefore, f of x does not, this f of x does not represent a PDF because when you substitute the value for 0, that is equal to negative 4. Next, we have here, so we will not proceed immediately with the next property because the first property does not fall here. So it does not, wala na siya ng function or it does not jibe with the properties that f of x is greater than or equal to 0. So therefore, this one is not a PDF. The second one, the third one is f of x is 0.5, x is greater than negative 1, and x is greater than less than or equal to 1. That is 0 elsewhere. So the first property is that when we substitute, okay, that is we need to graph this. So this is 0 and 1 and negative 1. So when we substitute negative 1, this is equal to 0.5. This is 0.5. This is uh, when we substitute the value for negative 1. Okay, negative 1, the result is, okay, negative 1, the result is 0.5. And we substitute the value for our 1 is still here, 0.5. So this follows, that is f of x is greater than or equal to 0. That's correct in this case. Okay. Because when we substitute the value for our 0 here, for example, with this 0, still this is 0.5. 0, 0.5. And negative 1, 0.5. And when we have to substitute, this is 1 and 0.5. So that's the concept. So in this is case number 1 and this is case number 2. We need to integrate. The area is equal to from -1 to 1, 0.5 dx. Okay, so area is equal to, this is 0.5x from -1 to 1. So area is equal to 0.5 minus -0.5, because we need to substitute this -1, so this 1, so the area is equal to 1 because we need to change the here the subtrahend, proceed to addition. So therefore this one is checked. So all the properties are checked, so therefore the function is a PDF. Okay, so that's it for example number 1. So let's proceed with the next example. Find the value of a so that the given function may be a probability density function. So we have here, by the use of integral calculus, so this is from 2 to 4, that's the interval. So this is a 12 minus 3x. So a integral of 2 to 4, 12 minus 3x, and we have to dx is equal to 1. Okay, so we have to integrate this one. So the result of this one is we need to take the constant. So a, so we have 12x. We need, after integrating, 12x minus 3x squared over 2 from 2 to 4 is equal to 1. Then after that one, we need to substitute the value. So a, we have 4. 12 times 4 minus 3 times 4 squared over 2. Then minus 12 times 1 minus 3 times 1 squared over 2. Then equals to 1. So we have to calculate. This one is 12 times 4, that's 48. A is equal to 48 minus 4 squared times 3 divide 2, that is equal to 24. Then minus 12 minus I2, this is rather 2. This is 2 to 4, so this is 4. 4 times 3 divide 2, that is equal to 6. Is equal to 1. So a times 48 minus 24, that is 24 minus 6 is equal to 1. So a times minus 6, that is minus, this is 24, rather this is 24. 24 minus 6, that is equal to 18. So 24 minus 18, that is equal to 6. So our a is equal to 1 over 6. So therefore the function is equal to 1 over 6, 12 minus 3x. So f of x is equal to, this is 2 minus x over 2 with interval of x is greater than 2 but lesser than 4. Alright, so that's it for example number 2. So please try this at home. Find the value of a so that the given function will be a probability density function, and sketch and state whether the function may be a probability density function. So thank you so much for listening, and God bless everyone.